Bismillahirrahmanirrahim. Today I'd like to talk about the sigma notation that is used for writing series. This here is the sigma notation. It is really only one of the letters from the Greek alphabet. It is the uppercase letter sigma. But in mathematics, it is often used to denote the term the sum of. So whenever you see this symbol, you read that as the sum of. You read that as a phrase, the sum of. Just like the radical symbol represents the phrase the square root of, the symbol sigma here, or the uppercase letter sigma, represents the phrase the sum of. Now here's an example of a series that's written using the sigma notation. The sigma notation has three parts. Something's written here, and something's written here, and finally something's written here on the side. Now, what's written below the sigma notation of here is the starting point of the series. And what's written above over here is the stopping point. So in this particular case, you start the series with n is equal to 1, and you go to 5, and then you get to 5, you stop. So n goes from 1 to 5. So the beginning of the series is from when n is 1, and the end of the series is at 5. And unless otherwise stated, n is an integer. So it will be n is equal to 1, 2, 3, 4, 5. Now what's written over here is the rule, or the formula that is used to generate the series. So in this particular example, the rule that will generate the series is 2n. So the way you would generate the series is as follows. Our instructions here might be to rewrite each series as a sum or expand the series. So all of this over here represents a series in a compressed, compact form. So if you were to rewrite this series in the expanded form, this is how you would do it. You would take n, and n would start out as 1, and then you substitute that over there. And then you go to n is equal to 2, and then you substitute it over there. And then 3, and then 4, and 5, and you would stop when n is equal to 5. Now, if this number over here was 10, you would go all the way up to 10. So here we go. So what you would do is you would substitute 1 in place of n to get the first term, 2 times the quantity 1. And then to get the second term, you would substitute 2 over here in place of n. So that's 2 times 2. And then the third term would be 2 times 3. And the fourth term would be 2 times 4. And the fifth term, the last term, would be 2 times 5. Now, this here is n. So you substitute here n to generate each term. So you can see you use the rule to generate each individual term. This particular series, as you can see, it's a finite series, and it has only 5 terms. Now, again, as I said, if this was 10, you would go to 10, and if that was 20, you would keep going up to 20 to generate all the terms of the series. Now, we don't leave the answer like this because it's not simplified. It would be mustahab, or it would be good mathematical manners to simplify this a little bit like this. So this would be 2, and this would be 4, plus 6, plus 8, plus 10. So this is the series that is represented by this notation. Here's another example. Our instructions here are again the same, to rewrite the series as a sum, or to expand the series, or to write the series in the expanded form. The way you would read this expression is the sum of the quantity a squared plus 1 all divided by a from a is equal to 1 to 4. Again, the sum of the quantity a squared plus 1 divided by a from a going from 1 to 4. To generate the series in the expanded form, again, we substitute a one individual term at a time. So when a is 1, this will be 1 squared plus 1 over 1. And then to get the next term, we substitute 2 in place of a. That would be 2 squared plus 1 over 2. And in the same way, to get the third term, we place 3 squared plus 1 over 3. There's a nice pattern over here. And finally, to get the last term, you would place 4. That's 4 squared plus 1 over 4. And thankfully, there are only 4 terms in this particular series. Now, you can simplify this again a little bit. So 1 squared is 1. Last time I checked, 1 plus 1 is 2. So that's just 2. And this would be 2 squared is 4 plus 1 is 5 over 2. And this term, this is 9 plus 1 is 10 over 3. And that's 16 plus 1, that's 17 over 4, I believe. And that's it. And this is the expanded form of the series. Now, we are not asked to find the sum of the series. And if we were asked to find the sum of the series, then we would have to add all of these up. For example, in this particular, this is going to be a little trickier, of course, but if you were to find the sum of all of these terms, you see it will come out to 30. So this here is the expanded form of the series, and the sum of all the terms here would be 30. The sum of these 5 terms would be 30, but we were not asked to find the sum of the terms. We were just simply asked to write the series in the expanded form, and that's what we shall do. Before we finish, I'd like to give you one last example here. Here's a series which is very different from all the examples that I have given before. Now, consider this one. Now, this series, again, is very different from all the other examples that I have given. You would read this as follows. The sum of 1 over n squared from n equals to 1 to infinity. Now, that's very different. This is an infinite series. You know, there are infinite number of terms. Clearly, we won't be able to write all the terms over here because there are infinite number of terms. But we can write the first few terms. Let's write the first 5 terms of this series. Again, you substitute for n, and n would be an integer unless otherwise stated. So this would be 1 over 1 squared, and then this would be 1 over 2 squared, and 1 over 3 squared to get the third term, and it's 3, and then 1 over 4 squared like this, and this would continue to infinity. Again, we can simplify this a little bit. This is just going to be 1 plus 1/4 plus 1/9 plus 1/16 plus ... or ellipses to infinity like this. So this was an example of an infinite series written using the sigma notation, and you can see how beautifully compact it is and how wonderfully easy it is to write the series using the sigma notation, starting from n is equal to 1 to infinity and writing the rule or the formula over here. Inshallah, next time we shall do some more example using the sigma notation in our quest for understanding series. Until then, as-salatu was-salamu ala rasulillah walhamdulillahi rabbil alameen. Assalamu alaikum.